Before we jump into 8.4, I want to remind us about matrix multiplication. We did matrix multiplication back in December, right before Christmas, so I know it's been a little bit. But remember, when we did matrix multiplication, we looked at the number of rows and columns. So this matrix had 1 row and 3 columns, and this one has 3 columns, or sorry, 3 rows and 1 column. We can only multiply these if these two numbers are the same, which they are, and our answer is going to be a 1 by 1 matrix. Okay? So remember how we multiplied this number by this number, and we got 4, plus this number times this number, we got -6, and this number times this number, which we got 2, and we added those all together, and we happen to get 0 for this one. Okay? Same thing here. We have a 1 by 2 matrix and a 2 by 1 matrix, which of course they're going to multiply, and our answer is going to be a 1 by 1. And the way we got that 1 by 1 matrix is we multiplied first row and column, which is 3, and then we added it to this, which was 8, and our answer was 11. Okay, so that was matrix multiplication. Hopefully you kind of remember that. The reason I bring this up is we are multiplying vectors today. So last lesson, we talked about vector addition and scalar multiplication. So that was where we were multiplying a vector just by like a number 2 or 3. We can also just multiply 2 vectors together. Okay, so if we're multiplying vector u times vector v, the way we do it is called a dot product. We multiply the x coordinates and we multiply the y coordinates and we add them together. So when you multiply 2 vectors, you get a single number. You get a scalar, not a vector. So that's kind of different. So we'll see a lot of examples of those, but it looks just like we did with matrix multiplication. Some properties of matrix multiplication. It is commutative, so u times v is going to be the same thing as v times u. That's what that first one says. If you multiply by 0, you get 0. The distributive property works. So if you have vector u times vector v plus w, you can distribute that u if you'd like. V times v, vector v times vector v, is the same thing as the magnitude of v squared. And then if c is a scalar here, you can multiply the scalar by u and then multiply by v, or multiply the scalar by v and then multiply by u. So similar properties to what you would be used to. So let's just do some examples here. We want to find these dot products. So like I said, we're going to multiply the horizontal components, 4 times 2, and we're going to add that to the y components when they're multiplied, 5 times 3. So our answer is 23. That's it. On the next one, we're going to multiply our x components, and then we're going to add our y components multiplied together. So we get 2 plus -2, which gives us 0. For c, we're going to multiply the x components and then multiply the y components, and we're going to add those together. So we get 0 plus -6. The answer is -6. And here we'll multiply our x components, the vertical components or the y components, and we also get -6. Okay? Easy so far. It does not get much harder. No panicking. All right. We're going to use properties to find these. So we're going to do u times v and then multiply by that by vector v. So let me write this down here. U is 3, 4. V is -2, 6. And then we're going to multiply that by v again. Okay, so we're going to do this part here in parentheses first. We're going to multiply the x's and add that to the y's multiplied by each other. So we get -6 plus 24, which is 18. Now, I didn't write this, but we still have this vector v here. So we need to take, well, that doesn't seem right. It is. I did everything right? Yep. negative 6, and 24. Okay, that looks fine. And then we're just going to multiply both these things by 18. We get negative 36, and that's a big number, 108. Okay, let's check out the next one. We're going to do vector u times u plus v. So vector u is 3, 4. We're going to multiply that by vector u plus vector v. And we're going to use our order of operations. So we're going to do what's in the parentheses first. We're going to add those two vectors. So we're going to add the x components. We're going to add the y components. We get 110. And then we're going to multiply those two vectors. So we do 3 times 1 plus 4 times 10. And our answer is going to be 43. I think something in the homework that they ask you is they ask you to do this stuff and then tell whether your answer is a vector or a scalar. So clearly, in part A, our answer is a vector because that's a vector. But in part B, our answer is a scalar because that's not a vector, it's just a plain old number. And then the magnitude of V. We can just do this the way we've been doing it. Remember, magnitude V is just modified distance formula. So we're going to take negative 2 squared plus 6 squared. Handwriting is a problem here. So we get 4 plus 36, so the square root of 40, which we can simplify that into 2 root 10. Okay. We will talk about some more applications of vectors in the next video.